I'm going to try something a little bit different for this next video. I am going to use models instead of using drawings, see if that's just something a little bit different to use. I'm going to be talking about isomers, both structural isomers and stereoisomers. So the video that you saw yesterday was all structural isomers, but in your reading you did do both structural and stereoisomers. So we're going to talk about both, and I'm going to go a little bit deeper into the structural isomers as well. So structural isomers are pretty simple. Okay, the first kind of structural isomer you have is when you're just talking about moving around a chain. Okay, so recall that isomer means that it has the same chemical formula but a different structural formula. So for example, okay, this is butane. Okay, all single bonds. Okay, completely saturated, nothing special about this, just besides the fact that it's butane. Now, this is C4H10. Okay, you can see that the blacks are the carbons, C4, and you can trust me if you can't see them all, but there are 10 hydrogens here. Now, the one way that I can make an isomer, a structural isomer, is by moving a chain. Okay, so I'm going to show you what I mean. If I take this hydrogen right here, okay, which is on this second carbon here, and I plop it off. Okay? Sorry, my model set isn't quite as easy to maneuver around as the ones that we use in school. So if I take this last carbon here, okay, this last CH3, and I plop this off, and I just have them trade spaces, you're going to notice that I form something quite different. Okay? Now, I did not add anything. I didn't take anything away. I just moved this hydrogen with this carbon. And you can see I have something quite different. This is still C4H10. Still C4H10. But now I have propane with a methyl group. Okay, so this would be methylpropane. A different molecule. Same same chemical formula, different structural formula. So that's the first way we can form a structural isomer, is by just taking carbons and trading places, moving chains around. The longer the chain, the more opportunities we have. Here I have pentane, 5 carbons, 1, 2, 3, 4, 5. Okay, 5 carbons and 12 hydrogens. Okay, 5 carbons, 12 hydrogens. Now, this molecule, okay, can also form isomers. Almost, I shouldn't say all, but most of the molecules that we form can have some sort of isomer. Not all of them, but some sort. So again, I can do something simple, like I'll plop off this hydrogen here, okay, plop off this CH3, and move it. Okay? So this is now methyl butane. So I had pentane and methylbutane, same chemical formula, very different structure. You can see you have the methyl group coming out right here. Okay, but again, this is very simple. It's just moving a chain. It's the same style, but I did this one again on purpose. I want to show you something. Okay, say I trade spaces with the methyl group and this hydrogen down here. Do I form an isomer of methylbutane? Well, let's see. Okay, so if I plop this off and plop this off and have them trade spaces, okay, on the surface it looks like I'm forming something different. It looks like it's going to be an isomer. But is it? No, it's not. Because if I just rotate this around, It's the same thing. This is something that you have to be really careful about. Molecules are three-dimensional. Okay, they move around. I can move them. Sometimes I can spin bonds even, right? Like these can all spin. That's real. That happens. So I have to be careful when distinguishing isomers if I'm forming a new isomer or if I'm actually just forming the same thing in maybe a slightly different way, and all I gotta do is turn it around or spin something and it'll be the same. So we gotta be careful with that. Okay, be very careful that you're not forming the exact same thing. Can actually make an isomer is by moving around a double or triple bond. So here I have, and it's a little difficult to see, but you can see the double bond right here. Okay, I have butene. This is one butene. You can see that the first carbon to carbon bond here is a double bond. Okay, and then singles after that. Okay, so this is one butene. Okay, C4H8. Now, another C4H8 is 2-butene. So all I'm doing is moving this double bond. I'm going to move it to this middle spot, okay, just by rearranging things a little bit. If I do this here. And now I'm going to have 2-butene, okay, on the second carbon-to-carbon bond, right? I got a carbon-to-carbon bond here, carbon-to-carbon bond here, and right in the middle is that double bond. This is 2-butene, okay? This is an isomer of 1-butene. Same formula, different structure, and this time instead of moving a chain, I moved a double bond. That I can form structural isomers is by moving around functional groups. Okay, here I have an oxygen and a hydrogen. Okay, this is an alcohol group. Okay, OH, coming off of the first carbon. This would be one propanol, right? 3 carbons, prop, OL at the end for the alcohol group. So this is one propanol. Okay, if I move the OH to the middle, now I have 2-propanol. All I did was move this hydrogen and the OH group, just changed places, okay, and I have a completely different molecule, 2-propanol. Okay, this is another way to form an isomer because this is C3H8O. Okay, so this is C3H8O, and so is 1-propanol. Okay, so I got my 3 ways. Okay, first one, moving a chain around. Okay, moving those carbons, getting moving methyl groups or moving ethyl groups, or taking a chain from the end of the main chain and making it a branching chain. Okay, that's the first way. Second way, moving a double or triple bond. Third way, moving a functional group. Now remember, not all functional groups can be moved like that, but alcohols obviously are one that can. All right, so that's it for structural isomers, but now we're going to move on to stereoisomers. Stereoisomers are different. They're different because they only exist when I have a rigid structure. Now, what does that mean? Well, before, when I was showing you molecules, I was showing you that things can spin and move and to not, and bend a little bit. And don't be afraid, well, not everything, but certain things can spin, right? Don't be afraid of spinning something and saying it's the same molecule. Well, when I have a double or triple bond, those can't spin. If you see here in my model, if I try to twist these, it doesn't work. Okay, with a single bond, like this one before, this will spin. This will spin all day long. This, however, does not. So if I have something like this, okay, this is a double bonded, okay, this is dichloro, because 2 chlorines, these are the green guys, dichloroethene, okay? where these chlorines are actually will change the molecule. Okay? So if I put it over here, I have something completely different. But I'm going to show you exactly what I mean here. Okay? This is an isomer. And, dropping it. And this is an isomer. Okay? Where I have one at the top, there is one at the top and one at the bottom here. Okay? Same chemical formula, C2H2Cl2, but you can see that they are in different locations. Okay? One here and one here. Where before I had them here and here. So how do I recognize them? How do I name them? Well, we call this cis-trans isomerism. That's what stereoisomerism is, cis and trans. So very, very simple. I'm going to keep it basic. Okay, this gets much more complicated. But if I have the groups that I'm talking about and they're on the same side, like this, okay, this would be the cis isomer. Same side, cis. Okay. If they are opposite each other, like this is the trans. So how I name it is I just name it as usual, but I put either cis or trans at the very beginning. Okay, even if there are numbers involved, I put it before that. Okay, so this would be trans dichloroethene. Dichloroethene. Okay, and you gotta have that rigid structure. Can't twist. So I gotta have a double or triple bond for this to, actually I have to have a double bond. Triple bond would be just one chain coming off. Have to have a double bond. I have to have a double bond for this to work. Alright? Alright, so you guys are gonna have a worksheet on this to go with this video. Hopefully this was helpful. And I will be posting more on isomers. I'm going to find some more videos to go along with what you've already seen, just because I really do think it's as easy as organic can be, even though it's a lot. There's not a lot to memorize, obviously. I do think this can be something that's difficult to see, and that's isomerism.